what you got for the first three? Yay! ABC? Oh, you're talking about something else. Yes. Yes. Out for this, no, that works for me. If it was an HTTP response, it would work like this, but your graph it works for me. Mathematically true. I'm glad you know the graph for that. Most people don't. Not continuous for all three, right?
Wait, Sam. Yeah. The maximum is where that double prime. You plug in those. Oh yeah.
All right.
You're right.
So there's a relative, there's an absolute min at
I'll let you go.
this is a tangent. Oh, did you find your zero from the first one?
I'm working on 25.
Thank you.
So then, so it'd be a positive start. So did you make a tangent line doing this? Did you take the that is so crazy. I don't know how to. The derivative of tangent is you can get like you can get a squared line and then you need to divide it.
Wait, isn't it tangent or positive?
Yeah.
All right.
You need to find the tangent. We need to
All right, how we doing, people? Check your answers to those, make sure that if they're not right, you correct your work, or find your error, or learn. Are we still cruising? Oh. All right, let's go to the notes if you don't mind. Finish the problem we're working on and turn it over to ultraviolet blue. Okay. So, curiosity, have you ever heard the saying, maybe you can complete this saying, any good doctor or mechanic knows this saying. When you hear hoofbeats, think horses, not zebras. Okay, that's a famous saying. Whether you know it or not is a different story. But anybody whose business is diagnosing problems and solving problems, like a mechanic or a doctor, knows that saying. When you hear hoofbeats, think horses, not zebras. In other words, what? What does it mean? When you have a problem, think about the most common, simple approach. It's the most likely. That goes to integration by parts. We're going to have this and U sub competing. And U sub is horses. Ultraviolet voodoo is a special case zebras. It's a once in a while, really useful, really cool kind of thing once in a while. A U sub is the big boy. It's the biggest. Yes?
Kind of elephant in the room here. Why is it called ultraviolet voodoo?
Good question. I will explain once I get to the formula itself. It's really a mnemonic for memorizing the formula. It really has, voodoo has nothing, if you're like religious, don't worry, it has nothing to do with voodoo. Okay? So, I will explain. So, the introduction, first of all, is it's an integration technique. You still have, so over here, there's one advanced limit technique you still have to learn. Derivative technique, you're pretty much all the basic Calc 1 techniques you have in place, with the exception of inverse function derivatives. Derivative applications, you still have a lot to learn. Integration techniques, you know a lot, but there's still this to learn. That's still Calc 1. Applications, you still have some to learn, a lot to learn. Differential equations we haven't done yet. And then advanced techniques. You'll learn some advanced techniques, some of which are Calc 2 in this class. But you have a lot of technique, and this is going to add to your technique toolkit, right? The tools you use to build an integration house. So here we go. First of all, when do you use it? Well, it's when you see a product. When you're integrating a product, that's when you use integration by parts. Now, we actually have U sub to deal with some of those cases. For example, say the function was sine cubed. Do you agree that if I took the derivative of that, I would be a chain rule derivative, the 3 would come down, you drop it to 2, and the derivative of the inside is cosine. And therefore, chain rule results in a product derivative. Do you agree? All right. Now, when you go to integrate by U sub really undoes chain rule. That's what U sub's main goal is. So if you were to go to integrate that, you'd say, oh, well, that's the derivative of the other. That must have been a chain rule derivative. So your answer would be sine cubed, because we would, if we wanted to, we could say, well, I'm going to let u equal sine, and du is cosine, and it becomes something like 3u squared du, and boom, that's u cubed, and we sub that, right? Are you with me? Okay. So U sub is the idea of what do I do when I see a product there and one looks like the derivative of the other, like we did a chain rule to get that product. You follow me? All right. If, however, you get a product where one is not the derivative of the other, the two terms really have nothing to do with each other, well, that's an ultraviolet voodoo or integration by parts problem. For example, x cosine of x, that's not a U sub problem. If it was x cosine of x squared, would that be a U sub problem? Yeah, you'd let u equal x squared, and du is 2x dx, and we could work with the 2, and that's not a problem. That's U sub. But no matter what you tried to U sub there, U sub would never. It just would never work. All right? Now, so this is probably 50 years into the calculus. They have big ideas in place, the derivative idea is in place, the integration idea is in place, but they're still trying to work out, well, what if it's this? How do you integrate that? What if it's this? How do you integrate that? Well, they playing around with this, they thought, well, how am I going to integrate this product when it's not a use-of problem? Well, let's start with derivatives. Yes, we get a product when we do a chain rule derivative, but when else do you get a product? When you take a derivative, what else gives you a product in your answer? I'll say it again. When you take a derivative, what else gives you a product? Yeah, the product rule. The product rule also results in a product in the derivative, yeah? For example, if I took the derivative of something, I might get x cosine of x as part of the answer. Now, what I'm saying is, what could I have taken the derivative of and had a product rule derivative that had x cosine of x as part of it? Take a stab at what it could have been. X sine of x. Let's try that. If I took the derivative of x sine of x, if I left the first the same, took the derivative of the second, wouldn't I get x cosine of x? Yeah? All right. So it seems like we're on the right track. Good call, Angie. The next part then. The derivative is the first times the derivative of the second plus second times the derivative of the first. So what's the second part of it? Just sine of x, yeah? All right, do you agree that that is a true statement by property? Yes. All right, cool. Now then, the next part they said is, okay, that's great. I know that's truth, so I'm building off something that's true. Is this fixed on yours? Does yours say original or original? Original. Oh, what does that mean? Okay. Now, the part that we are interested in is trying to integrate that. So let's get that by itself. Let's say that x cosine of x is the derivative of x sine of x, which was on the left to begin with. And then we're going to subtract over sine of x. Do you agree that that is the same statement, just with stuff moved around out of brains? You cool? Okay. Now, our whole objective was to figure out how do we integrate that. Well, integration is just like all other operations in math. You can do integration to a side of an equation as long as you keep it down, so long as you do that to both sides of the equation. So I'm going to integrate both sides. If I integrate with respect to x, so would you throw on an integral there of, oops, I need to land with the differential x sine of x minus sine of x, all with respect to x. All right. Now the left side is what we're trying to do. We couldn't integrate that before. We're still trying to figure out what does this equal. So the right side is going to be the answer here. Now, I think you'll agree that this is a difference of two things. Can I integrate the two things of parts of a difference separately? Can I split the integral into two? You can. That's okay. So this is the integral of the derivative of x sine of x, and then minus the integral of sine of x dx. Well, cool. The first part's pretty easy. What's the antiderivative of the derivative of x sine of x? X sine of x. And what about the antiderivative of sine of x? Cosine or negative cosine? Negative cosine of x. At that point, we've integrated, so we need to pick up a plus c. So our final answer is something like x sine of x plus cosine of x plus c. And we were able to integrate something that had not yet been integrated. Now, let's think of this more generally. This worked great for x cosine of x. But instead of doing this kind of whole process every time, let's do what's called math analysis, which is to analyze the process, not this problem, but the process we did for this problem, so we could develop a formula that could be used and avoid all this background work. All right, so let's say that we took the derivative. Actually, would you say let u and v be two functions of x? They are not variables. They're functions. It's pretty common in calculus you do that, especially in F2. or and in vector calculus as well. U and V are functions. So think of them like f and g. F of x and g of x. They're functions. They're not. They could be, you know, x squared plus 2. They could be sine, but they're functions. They're not just a variable. All right. Now, if I took the derivative of uv, then notation-wise, we know that when we write that little d, that means take the derivative of that. Yeah. Now, by product rule, isn't that first stays the same, derivative the second? So I'll call it uv prime. Actually, I'll call it udv. I'll call it udv plus first stays the same, derivative the second, plus second stays the same, derivative the first. What's that? Oh, it's like food. Okay. Now, we rearranged a little to isolate. So we wanted to isolate udv. X cosine of x is kind of what we looked at here. Well, that's what udv was. So if I isolate this, then don't I subtract v du over the voodoo over? So it's the derivative of the product minus v du is udv. And then the last thing was we're trying to get an integration rule. So we're going to integrate each side. The antiderivative of udv is the antiderivative of the derivative of uv minus v du. That whole thing antidifferentiated. And so, the antiderivative of some kind of product of two totally different functions, u and dv, is, well, what is the antiderivative of the derivative of uv? UV, ultraviolet, minus the antiderivative of v du. We don't know what that is. We'll have to find that, but it's blue. Now that is ultraviolet voodoo, integration by parts. If you remember ultraviolet voodoo, then the only thing you do need to remember is that it's subtraction and it's the integral of voodoo. But that doesn't just flow very well. Ultraviolet minus the integral of voodoo, that just doesn't flow. So that is the integration by parts formula. Now let's check it out and talk about how a problem will look like. Now we just did this one, but we're going to do it more like applying the formula. Okay. The very first thing you do is, in order to use this, you actually need 4 different things to be found. Now they're saying let u equal dx. That's the u. And the dv is cosine of x dx. Now, the first time through, this is going to be a lot of, just stick with me and we'll gradually say, oh, okay, I see how it works, right? Now, after you have u and dv chosen, that's really, we said, all right, in the problem, what will I let u be and what will I let dv be? After you've chosen those, then you actually have to find little variations on the theme. If u is x, then what's du going to be? dx. Because du means I take a derivative or du. Okay? Likewise, if dv is cosine of x, and the formula calls for finding v, then I need to know what v is. Well, v is, then if dv is cosine, that means the derivative is cosine, which means v is sine. So v is the antiderivative. Those are 2 little problems within the problem. All right, so now, if you write the formula, integral of some product u dv is ultraviolet uv minus voodoo. And then below that, you write what each component is. u dv is x cosine of x dx. That's the problem. And using our little, we usually make this a little table of 4 things. I don't know, that's just how I was taught. uv. What is uv? X sine of x. Minus v du. sine of x dx. Okay? So we wrote the formula, we substitute, and now we need to evaluate the integral. So our final answer then is x sine of x. The antiderivative of sine is cosine or negative cosine? Negative cosine, so it turns to minus negative or positive cosine of x. And at the end, then after I've integrated everything, I think, see, that is my antiderivative. Right? Now that is an agreement with what we did, and it might seem like that's actually much more work than what we did to start with, but you'll see as you get better, it'll go clean up later. So, here we go. Do you feel like you want to try one on your own or walk through another one together? Walk through it. Okay, so the very first thing you do is you identify the four pieces. In this case, they tell you that u equals x. Now, in a second, just like in u sub, I started off saying, all right, u sub, let u equal this. I told you what to u sub. Eventually, you work until I know what to u sub. Well, that's going to be what the backside is. You need to eventually know for yourself, what do I make u, and what do I make dv? We'll talk about that in the back. But right now, I'm telling you, u is x, and dv is sine of x, dx. How do I find, if I have u as x, then I need d. du is dx. And if dv is sine of x, then v is the antiderivative of sine. Is that negative cosine or just cosine? Negative cosine. It's negative cosine. That checks because the derivative of negative cosine would be positive sine. So that's cool. Now, I write my formula, my basic formula. The more you write something, the more you remember it, and the more quickly you get it into your memory. So write the formula. Not to mention, it serves as a blueprint for you just to plug stuff in. u dv is the problem. So it's x sine of x dx. Use the table to pull for the right side. What's uv? X negative cosine of x. Let's put the negative out front so it's called negative x cosine of x minus the integral of voodoo. Negative cosine of x dx. Okay? Now the left side is the problem, so we're not going to touch that. But the right side is where we're going to get our answer. So minus and negative is just integrating sine. If I integrate sine, call that positive sine, I don't know. Oh, just go slow. What is the antiderivative of positive sine? Is it cosine or negative cosine? Oh, because I already integrated? What's that? Not bad. Okay, sorry. What is the antiderivative of cosine? Is it sine or negative sine? Sine. Now, just like always, I could check my answer. If you did a derivative on this, you get a partial derivative here, and that would actually cancel out, and you'd see that it does, in fact, equal x sine of x. Checking is always good stuff. All right. Now, I told you you're going to have to figure out how to choose u and dv yourself. There's definitely a right and a wrong answer. It's not like you can be a total fool and it'll all work out. You have to choose u well, just like in u sub, I suppose. So just to get you a feel for what goes into that choice, let's look at this problem, x cosine of x again. And if I tried this two different ways, I'll show you that one way works and the problem gets easier and I get the answer. The other way is a total disaster and the problem actually gets harder. So let's say that in doing this, I let u equal cosine of x, or u equal x. If u equals x, I know we just did this, but let's go through it again quickly. dv is therefore cosine of x dx, yeah? du then is dx, and v is the antiderivative of cosine, which is sine. So that when I go to integrate u dv represents a product of two functions that aren't related by a derivative relationship. Then it's uv minus v du. uv is x sine of x and voodoo is sine of x dx, yeah? Now, that's good enough. The point of this is not to get the answer again. We've already done this problem. The point of this is to get this done. This is what makes that choice well. This integral is easier. It can be done. And that's why integration by parts work. Now imagine if, instead of doing it that way, keep in mind the order matters not one whit, okay? The fact that the x comes first in the problem does not mean that x is u. Okay? It could be that I could have said, well, I'm going to let u equal cosine of x. And therefore dv is the x and the dx together, even though they're not next to each other, that doesn't matter. Now if I did it that way, then I would find the du that goes with that u. If u is cosine, what's du? Sine or negative sine? Negative sine. And negative sine or just sine? Oh, negative sine, yeah, sorry. V, I was thinking integration. What's, if dv is x dx, then what's v? What's the antiderivative of x? X squared, 1/2 x squared, or x squared over 2, right? Okay, now stick with me. You'll see the point of having to choose well. If I then did my ultraviolet voodoo substitution here, uv is x squared over 2 cosine of x, and that's not a problem. But voodoo, x squared over 2 times negative sine of x dx. Now, this is what makes choosing well or choosing badly the decision, or what tells you if you chose well or not. This, that would be the next step. Integrate that. Would it be better or worse than we started? Yeah, it's actually now worse than it started. Not only do we have a mixture of two functions, but now the algebra term is even worse. So this is worse. That, or I spelled or worse. Sorry, it's been a long break. This is worse. That's what is clearly a bad u choice. If after choosing your new integral is worse, you chose bad. You need to go back and say, oh, I think u should have been this, not that. All right. Now there is a, I'm not big on memorizing stuff, but there is a mnemonic that's pretty common. In terms of the best way to choose u, the best possible u, the best one is log, especially natural log. The next best is inverse trig. So if you had like arctangent, that would be a good u. Down the ladder then, algebraic. Now that would be like x or x squared or dx, something like that. Those are all algebraic terms. Trig terms are bad. They don't go away. And exponentials are really bad. E to the x doesn't go away like x did. So those are getting into terrible use. Now then, let's take a look at a totally new problem that's not that same x sine of x, x cosine of x, to show you that there's lots of these types of problems. Now, this, remember, first in course, is that a u sub problem? No, okay, it's not a u sub problem, it's not a chain rule problem, one's not the derivative of the other, so it's not u sub. I'm thinking, well, maybe it's a product that's a ultraviolet voodoo kind of problem. It's a product rule kind of derivative. Now, let's go with our choice. If the best u is natural log, then in this case, we're going to let u equal natural log. And therefore, dv, remember, the whole formula is the original problem is a u and a dv. So in the original problem, you have to figure out, all right, what's u, what's dv? And we chose u as log, which means dv is everything else. And so, x dx. Now, after you made those choices, then you have two consequences as a result. If u is log, then du is 1 over x dx. And dv equals x dx implies that when you integrate, v is 1/2 x squared. squared. Now, if you're thinking, gosh, that looks just like the one we did, you said it was terrible. Well, it's different because the natural log is going to help us here. Now, the formula we said is ultraviolet UV, and you sub in for the four components. So UV, what is it? Natural log of x times 1/2 x squared. You can write that with the 1/2 up front if you want. Minus voodoo. And that's 1/2 x squared and 1/x dx. Now the whole point is you're supposed to get a better integral. Do you? What's the new integral when simplified? 1/2 x. Is that easier to integrate than x natural log of x? Well, yeah. All right, so if we integrate that, then the 1/2 is fine. What do you get when you integrate x? And then combine it with a half all in one, shall we? 1/4 x squared. Do you agree that the antiderivative of x would be x squared over 2? And when I combine that with the half that was already there, I'm getting a fourth. And then I get a c. Boom. There's my answer. All right, you try. Talk it over if you're not amigos. What are you letting you equal? That's the question we should ask before proceeding too far, if you're not sure.
X e to the x minus e to the x plus c.
All right, Maddie, what'd you let u equal?
X.
And therefore dv is e to the x dx. Cool. All right, so du then is just dx, and v is e to the x. So the whole point is, did you get an easier problem? X e to the x minus the integral of just e to the x dx. And so, did you get x to the x e to the x minus e to the x plus c?
Yes.
All right. So let's talk, we might have to finish these notes tomorrow. Tomorrow we're going to just do a little more practice on it. So we'll work for what? Let's do one more. Sometimes this will require a little more skill on your part. It's going to be a mixture of, I call it W sub because U is kind of taken, but it's not even required that you sub. Let me explain. So this, do you agree it's not a chain rule, it's not a U sub problem? Okay. So let's go with integration by parts. What shall we let U equal? 3x, right? And therefore dv is sine of 4x dx, yeah? All right, now du is obviously pretty easy. Du is 3dx, okay? This is where I say w sub, because to integrate sine of 4x, you're integrating something with a function within a function. Now, I don't require that you actually u sub this or w sub this. If you can, I would prefer that you integrate this by guessing. There are really only two possibilities for the antiderivative. Either 4 sine of 4x or 1/4 sine of 4x. Which one works? Not sine, never mind, that's not two possibilities. Oh, that's stupid. 4, actually it could be negative. So, just you tell me, what is v? Just by guessing check. Say you try 4 cosine of 4x. Does it work? If you said v was 4 cosine of 4x, then when you take the derivative, shouldn't it be that? And is it? No, you actually get another 4, so 4 is not a good call. So that didn't work. What else could it be? Negative 1/4. Does that work? If you took the derivative on negative 1/4 cosine of 4x, would you get sine of 4? Yeah. Now, if you want to use sub that, go for it. But I think you'll find it much quicker if you could just kind of guess and check it. Please take the time to verify it was right. But that's a quick way to do it. All right. We will finish tomorrow. Lovely to have you back. I think I'd like the first period for 7th period. Have a great day. We're just going to do that every day. Tyler? We're going to do that every day.
That's literally